Our next talk is from my esteemed colleague and friend, John Gingerich. You're still my friend.
Still alive today, barely. My talk actually follows quite well from behind Lee's talk. I'll probably hopefully provide a little infill to some of the points that he raised, especially when it comes to the innovations that took place in oil and the analogs for mining. I was originally going to take a talk and talk about all the technology we've done and do a track record, but I think looking back at the last 15, 20 years, I came to the conclusion that we had to find the missing pieces, and I don't think it's going to be found the way we typically think. As we all know, we're in the deja vu, and when Ken and I had jobs, we worked for companies who back in this period of time, in the late 90s and 2000s, were desperate for innovation and new technologies, looking for magic bullets. And in actual fact, we were working in this little bump here, and we did lay everybody off in periods of time. We went through massive restructurings, and industry did a lot of soul searching, and it was an abysmal time, as bad as it is now, but we went from about 4.5 to 2, and amazing years after we went up to about 22. So we went up tenfold, and so the cliff we're coming off now is certainly a drug high. So now we're starting to see the talks again. How do we do better? How are we going to survive with less money? How are we going to be more efficient? And we're revisiting all the same discussions we had about 15 years ago. And what happened the previous time is worth looking at. We went out and we did do an awful lot of restructuring, downsizing, and I'll go show a slide later of some of the things we came up with. I think we invested heavily in technology. We were looking for not a single solution, but any solution, and all kinds of places to look for improvement. And as I said, there was this period of where we were struggling, and then we went to this wonderful time. And what actually happened is, as drunken sailors, once you got a bottle, every necessary element of everything we were trying to do became irrelevant, because when I was working at Miranda, then we were 84-cent copper, and we went up to $5 copper. It forgives all sins. And as Lee pointed out, the cutoff grades dropped, and immediately we created all kinds of resources around the world, and deposits that were marginal went into production. So we flooded the market. And worst of all, we still continue doing the other part of our exploration in the same way. And so the question came, do we need more technology now? And I'd look at it, and people forget, we're in the exploration business. I'm not saying there aren't reasons for technological improvement. There always are, as Lee pointed out. Incremental change does create certain values. But in the game of exploration, what we're really required to do is go find that new ore body. Some of the incremental technologies and higher precisions maybe help extend the ore body or help more. When you're down at 1.5 kilometers in Sudbury, and I know Alan and some of the work he's done, these technologies we're working on are essential. But then you're looking for something that's off the end of the drift. It's down 2,000 meters, and it has extremely high value. But you're not applying those technologies in greenfield environments. So if you think about it, we're really, in all the methods we apply, we're measuring a delta. If there's not a contrast in density or chargeability, or it gets masked. But the reality is, there is a pathfinder, and generally it's direct, but sometimes indirect. Even the discussion on the scorpion, they found it looking for a massive sulfide. They didn't necessarily do a thorough job initially in understanding the sequence of rocks, but in the end, they never found more except another massive sulfide. Maybe there is a gap if you're looking for a pure oxide play. But reality is, what the gap was is the failure of the exploration teams to have the proper full team and balance, and looking at, as we said, Voisey Bay, they were looking for diamonds and found Voisey Bay. We need to remember sometimes the nature of the deposit we stumble upon may not be the one we're looking for, but hopefully we're smart enough and systematic enough to find it. So the question I asked, or was asked, is why does exploration continue to fail? We hear it. The Ottawa product went in production, but they're largely old deposits or expansions of existing mines. And the the question is, can we do something better? Is there really a radical technology that's going to come out there and make it easier? When I was at Miranda, it was, fund the megatemps, fund the distributed arrays, fund whatever you thought you needed to find improvement. And I know with BHP, they had the Falcon. There was, can't remember the name. What was the AEM system from Anglo had Spectrum, and everyone had their version of what they thought the magic bullet was. And the curse of that magic bullet is we tend to apply it once we believed in it without discipline. We went out and all of a sudden, when you have your megatemp system and you find one blip was successful, it becomes, scorched earth plan for the next 5 years. And what comes from it is essentially nothing. And I think as I've asked around, and despite what I think a lot of great technological innovations that occurred, and some under my stewardship, the end result was essentially poor exploration practice. And we don't have a long list of, look at all the megatemp discoveries. So here's all the Falcon discoveries. In many cases, we flew existing deposits. We can demonstrate anecdotally. Look at this, we would have found it. But we haven't been able to take that methodology out and with an exploration team, go and find the next one. At least not very successful. There are obviously some discoveries out there, but the industry, on average, given the $20 billion spent, is getting a very, very poor return on its exploration dollar. So back when, like I said, when I still had a job, we had hyperspectral, and this is actually the Perseverance, which was the catalyst to literally probably $100 million worth of megatemp flying in North America. I probably was the architect, or I'm to be blamed for that. I don't think anything came from it. But and there's the Falcon systems, and the other one was, we talked about 3D seismic. We even demonstrated that we could do 3D seismic in high velocity rocks, and drilled a target down 1,150 meters, and with controlled drilling, hit it in the 50-meter box, and there, my God, was massive sulfides as predicted. Isn't worth a dime. And the cost of the survey is ridiculously high. So, but if somebody says to me, if you can, there's down there at 1.5 kilometers or 1,100 meters, you find me this deposit, I can afford to sink a shaft and develop it at these prices. We have the methodology to target it. We can target down to over a kilometer. So, do we need new methodologies to see deep and deep search? I think the answer is no. I think the improvements in the EM systems since have really, and even the processing, largely again go to guys like Kim. Signal to noise was always an issue. We had a lot of power, but the greatest innovation probably since these systems came online was our computing capacity and our ability to do better signal to noise and extract those weaker signals from a deposit that's down 200 meters or more. So from an exploration point of view, unless you're in a camp where I'm justifying something at 500 meters or deeper, we have all the tools to penetrate the ground and effectively search, especially when I went back to the original slide, or one of the previous slides. The targets we're after, to be economic, have dimensions of 5, 10, 20, 30, 50 million cubic meters. These are not small targets. They're not, you think about it, you make it 30 meters thick, and it has the rest of the dimensions become by a kilometer. You don't need 25-meter step-ups to hit it. So what happened? Like I said, we did make a great investment, and I said, did we really have a better discovery record? And the answer is clearly no. And as I said, I use this example. So what happened? Why did it fail? And so if we're going forward this time, what needs to change? There certainly will be people willing to invest. Companies are navel gazing. They've laid off all their exploration groups, but again. And so they're willing to maybe cobble more money to an innovative idea, thinking that somehow that might get them back on the magic bullet solution again. And I suspect we will see some of that. But as I said, the real question we have here goes back to the definition of insanity. We've done this. And if we're not going to do something different this time, we're going to have the same outcome. And as I said, while and I agree with Lee, there are continuous improvement and efficiencies to be had. But our primary objective and our primary purpose in exploration, we're really missing the boat. And that's really where I'm focusing on, because I don't want to undermine the good incremental science and that is being done and necessary, but our job is to go into the field and find the next Kidd Creek. And the Kidd Creek is a huge target. We've been chasing this for our entire careers, and you don't find the next one. And I point this out, this goes back to Lee's question, is why, with the oil industry, why they're successful. I'm going to go speak a bit more about that. But a simple definition, of course, we're looking for ore. And by definition, it should be commercially, there's not just the grade, but there's a size and a volume that goes with that. And often we get caught up on showings and somebody says, well, it's a 25-meter step out, or I missed it when I stepped out 50 meters better infill. It's illogical. You already have the answer. Your data should be telling you the prospects of, if it's a massive sulfide deposit, there's got to be a density contrast. There's got to be some sections of magnet. What are the signatures that are there that you could have somehow missed this beast that's so large? Well, the other thing I wanted to point out, that even Wikipedia got it right. It's organized professional form mineralization through services and prospecting generally there, but it's a much more intensive organized professional form. And I think exploration still, I had bosses who keep thinking that guy needs a hole, project needs a hole, or the geologist who doesn't have a project is somehow a bad geologist. In fact, we would incentivize people to get bad projects, because if you didn't have a project, you didn't have a job. So, and we even had a bonus scheme at Falcon Ridge Noranda where if geologists could increase their budget over the year, they must have been doing good work. So the incentive was to spend and to get a project, not to say, no, this is a bad project, not to filter it out and put your money elsewhere. We had a motivational bias in our business that rewarded bad behavior. So this goes back to some of the questions that Lee was talking about, the oil, what happened in the oil business. This is an extraction I took from Rose and Associates, and back in 2003 I gave a talk at the PDAC about risk management. And that talk fell from what Rose and Associates had revealed about what went on in the oil industry. And if we recall the slides by Lee where he had that, first of all, the big social spike in the 70s, and then another one in the 80s. And what Rose had documented in his research was the exploration record decreased with the increase in budget. We actually became more inefficient with more money. And his rationale was that managers would submit their $100 million exploration budget. Management board would cut it back to 80. He'd just go down his list and clip off at the $80 million line. You came back to him a month later and said, prices are up, here's $200 million. He didn't go out and find more projects at the same value funded. He just moved his bar down. And then you sent your people out pursuing projects that were at the bottom of the list. They weren't focusing on really the higher value opportunities. So we got busy. And I think this happened in this last mineral cycle. Everything was ore. You could go put a whole press release, everything was ore. So we're all happy. We all did very well. But what was really happening is we were destroying value. We were drunken sailors just looking for mineralization. The definition of ore somehow evaded us. And the thing that Rose pointed out, what he brought to the oil industry is, when I talked to him in 2006, 14 of the 16 largest oil companies in the world were his clients. And most of what Lee was pointing out, he brought out the 5 innovations, and what they really brought was team. What they basically said, we had to eliminate bias from the system. It was the geophysical, it was the geological, it was a hydrological, it was all kinds of solutions that were required. And the concept they also brought in is to change the definition of technical success in the same way Lee says, what's innovation mean? What he's saying here is, for it to be a technical success, you had to have hit a target that was essentially a plateau. In our case, it would be an ore forming process. Is that if you just hit a conductor, because you were drilling a conductor, that's not a technical success, because that's part of our technical performance. Justifies our being hired. But our job was to say, that should have been a massive sulfide. So we drilled conductors without the input of the geologists would have been faulty, because we can drill graphite all over the world. So their definition is, if you do not hit something that could be potentially an ore body, it's a failure. So if you go back to our industry, how many thousand holes of EM conductors I've drilled in my life and come up with not an ore forming processes? Those were all technical failures. However, at Miranda, I got bonuses because my geophysical group had over a 95% technical success rate. So my team was very successful at targeting conductors, mag anomalies, whatever, we never missed. So my performance rating was based upon, geologist said he wants a survey, can you give him a hole? I gave him a hole. But reality was, we needed a team decision as whether that conductor was really in the right rocks. Was it in the right place? Now, sometimes we don't know the right geology, but we're not asking necessarily the right questions. So this is essentially, so this was this frequency distribution, this log normal distribution, which is a straight line of deposits and grade. The deposit sides and grades all plot along these lines. So your probability of, once you hit a deposit, you could plot up, listed all the massive sulfides in the world, and if you needed 50 million tons at a certain grade, it would actually come off that curve. So you report two different things to your management. I have a very good team, we're 70% success rate, but this rate, Mother Nature defines it. Once you hit it, you won't know what the grade is and the size until you drill it up. But you certainly know something about the size if the conductor's only 200 meters long and there's no gravity known. So there is some things we can add to that screening tool. So here's the basic problem. We accept poor performance. This is from Andy Green. There's all kinds of different people published on that, but the story generally is we need 1 in 2,000 targets, or in the cases came from the government site, we need 1 in 10,000 projects to become a deposit. Why the hell would anybody fund us if that's our tracker? It makes no sense whatsoever. We boast about, we publish these as inducements to get more money. The reason we're poor at our job is look at the stats. They're stacked against us. That's bullshit. Tell you the truth, it's bullshit. It shouldn't be this way. And like I said, because we accept this, we've never asked the right questions. And do we really have a clue how to fix our problem? What are we working on? Do you want me to come up with a new tool? And I don't think it's a new tool. We haven't basically, I don't think you could say to somebody, why did a project fail? I often got the view when we ran a survey, we didn't find something. Oh, the geophysics doesn't work. It's not that we screened the project and we should walk away. Geophysics didn't work. So what are the reasons? Is it the wrong belt, wrong geology? Wasn't the right alteration? Was no ore forming processes? These are all the kind of criteria that establish whether it has a hope of being a deposit. And we go out and explore, looking for a conductor, and the conductor has to mean something in the story. You know, what does the geochemistry mean? Dick was talking about models. What chemistry are you chasing? What is the meaning of your chemistry? It goes back to what is your target objective. And as I said, if it's just hitting targets, I'll guarantee you the geophysical group will be pretty efficient. I put this example in, it's showed up in a couple of my talks, but back and in my latter years at Miranda, I started to worry about the fact that we had a good inventory of technology, we didn't seem to be going very well with it. So when we brought in hyperspectral, one of the questions is, where does it fit? It's obviously a tool, it's not a magic bullet. So we sat around geologists and said, based on what you knew about Chile, it's great, there's no trees, no vegetation, but you know, what are the parameters you typically knew about an environment you were working at? And we rated our understanding, a chance of being in the right age rock and the right structures, and these are the confidence levels. And I said, well, reality is the chance of discovery is really the multiple of your probabilities here. And that said, well, really you only have 1.3% chance to be successful. And I said, well, that's actually probably in line with what we were finding was our success rate. But when we looked at the hyperspectral, well, we could find out through the use of hyperspectral, prove and know that there was alteration and prove some of these things. We could come in and we improved our ability to recognize the right the alteration signatures, that we said our chance of discovery improved. And in actual fact, when we looked at the stats, our cost and our performance did go up by 15-fold. Didn't lead to an economic discovery, but at least we were on the right track of applying the technology to a specific problem. We needed to get better understanding of where the alteration was. Protrusions all over the place, but it had to have all the right parameters. So today, we go out and the world's our oyster, so to speak, and we pick a pot, we pick the Abitibi, and then ultimately we end up with this little patch of dirt, and we said, I've staked it. There's an ore body here. The reality is, I'm confident that unless it's exceptionally deep, we can find that ore body. By the time you stake the claim, its future is defined. We have the technical capabilities to screen that property to 200-300 meters. So the real question becomes that we spend all this money, at some point we get the data that tells us it's not worth drilling, but we still drill anyway. But the other point about it is, when I really looked at this, I think this is where our problems fail. And it's why companies keep going back to, put me back in the Harker Holloway, the Dester Porcupine. Why? Because you know you're in an ore-forming environment. You used to know that you want to drill on one section, you know where on the section to fill. Where as soon as you step out into the green field, you don't know what the geology is, or you have maps that you don't think are terribly accurate, or there's cover, or you don't believe you have the methodologies. We all know geochemistry doesn't work in the clay belt, right? So we automatically eliminate a lot of turf, or when we go to it, we fall back to, as I said, bind type applications of geoscience without any thought to a collaborative team approach. We're not solving the problem as Lee pointed out. He had 5 pieces to that equation. We do have exploration teams. They should be part and parcel to what don't we know. And in some cases, the best thing to do is to drill a strat hole out there. Before you do anything, why fly the airplane? Are we in the right rock? Somebody said this is a great belt. Well, prove it. Before we end up spending tens of millions of dollars in airbornes and ground geophysics, because once you fly the survey, you will stake land. You're destined to stake. And if you stake land, and you survey it, and doing some geophysics, you're destined to drill. You're down a path of just, this is what we do, right? Ken pointed out, it's like calling in the SWAT team, right? Somebody says, we got a disturbance out in the middle of the Abitibi. Well, here we go. We're sending our exploration team. We're going to shoot something. Right? We're going to execute on the plan, because that's what we do. But I think this is where we fail to really understand what we're doing wrong. Why did that program fail? And not necessarily because, not blaming on the geology, is because we're part of the exploration team. Geophysicists should have said, well, what's the characteristics of the target? Are we in the right environment? It's not somebody else's job to say, send me to the field. The only way we're going to be innovative and beat this issue, you've got to step up and say, be part of the decision process. And a process that gets you even to this belt, into this place. You should be invited to the chat early in the process, not at the end. So, as I said, it is a process. In exploration, like ore delineation, we have to select precious areas. We have to find out. And I think what this problem is, we do this part poorly. We have to be doing it poorly, because as I said, greenfield discoveries are almost non-existent. So we are doing something very wrong. We get caught up because somebody looked at the rocks and said, oh, I had a beautiful showing. Stake and run, and once you're hooked. Or, in the case of Miranda, we just flew 30,000 kilometers of airborne EM, and by geez, I'm going to drill 95 conductors, because that's what I just spent a fortune looking for. And we should have flown the surveys after, more selective, different kinds of surveys. Once we had established exactly where we thought was the most prospective places to be looking for massive sulfides. But we just flew every greenstone belt all over again. You can go back to the archives in Ontario and Quebec. These belts have been flown 10, 20 different times through different waves of exploration. And of course, the new Megaten was better than the old Quester, and there's always a reason to fly it one more time. And in some cases, it's just for assessment. But we really need to be rethinking, if it's for assessment and you don't know what the geology is, drill the strat hole. It's a dirty word. When I was exploring, nobody wanted to talk about drilling strat holes. I think strat holes are extremely important, because I said we waste a lot of dollars exploring in unproductive terrain. So something, I ran again, because we were in that period of how to get improvement, we got on the Six Sigma train, so I got my green belt. So, all right, we're gonna solve the world. He's a black belt, hell, he's just like, I got to turn my back on. But one thing I did really appreciate and learn from the process was essentially that if you want to improve something, you're going to have to be able to analyze and measure it. And then you have to set up parameters. And like I said, we don't know why we fail. So until the industry starts saying, what is it I was supposed to do? How do I perform at these certain levels? You can't go back and improve your performance. And I think that's why I said, I don't think we need new technologies. We need to start figuring out how to work as a team and apply the technology we have. There's great geologist research centers, our understanding of geologic models, our understanding of even geochemistry, our analytical skills, our capabilities have gone way up. We have lots of ability, but what we don't do, there is no measurement. There's no, post-mortems are called witch hunts, right? You don't want to go back at the property and after it failed.
We didn't even do one in Noranda after the failure of Magnolia.
Yeah.
The only real postmortem on Magnolia, the $1 billion, and that's another example, just to paraphrase that's a comment. What John says that, when you fly 1,000 kilometers of airborne, you're going to drill. Well, when you build a $50 million pilot plant, you be sure you're going to build a $1 billion plant.
Yeah. So, as I said, I think to me, and the frustrating part has been, as I said, over the years, even when I was with Durand, I said I did very well because I learned to jump the hoops. If people knew I was involved in all kinds of technology development, so I got bonus here, so I don't bonus there. I won Miranda's technology board and got another board. For innovation, it was great. But I was actually employed to find ore. And the metrics, though, that they were using to measure my performance, I think were wrong. Is that in the end, our team had to be measured on how many times we hit an ore forming process. Because we were all convincing ourselves that, oh, we hit the showing, I found mineralization, that was fine. To the geologist, he explained the occurrence, he gets a check mark. Where in the end, what was really in the rocks we drilled? And did we waste money? And should we have not drilled that in the first place? Did we know before we started the drill hole it was just a Hail Mary? Why are we drilling Hail Mary? So I think there is a way to get to how to improve. And I think through the Six Sigma, we did learn that you got to analyze, you got to map out your process clearly and then figure out how you're doing in every one of them, as I did with the porphyry, an example, to focus your research. What is the gap? Is it targeting? I don't think it is. It's property selection, recognizing alteration. I think there's areas in there where, like I said, I've seen greenstone belts all over the place flowing, every inch of it. And yet, there have been drilled before their maps. What is the rationale? Have we gone to the assessment files to prove that this is a really productive environment? Is there signs of the right alteration? We don't ask the question, but we have money, and it's open. And there was a showing back there from '56, so let's go give it another shot.
5 minutes, John.
Okay, so we cannot identify until we identify the priority problems that we can't improve. So I actually don't know where we fail. I don't think we're in the targeting side. I think somewhere in our ability to select and screen properties. Because if we're 1 in 2,000 or 1 in 10,000 exploration places, that's a horrific number. And if we actually put that, if the guys in financiers really digested what we were saying, they'd never give you a cent. Because it's worse than gambling. And motivational bias. And as I said, this is the thing that, the idea of sometimes we follow the herd, right? And there's certainly, that will bias the decision. No, this is my pet project, I've worked this is the guys, the experts. We have to listen to this person. He's the expert of photography, or he's the expert in Noranda. And therefore, everybody else has to stand back. Their opinion's only is worth less. And that person's motivated because why? They increased the budget to get a bonus, so they get a pay increase. They're not motivated for the right reasons. Ego and the reward systems is going to give them reward if they can convince you to give them 20% of the budget. So as I said one option to this is risk management I talked about. And I think right now, the oil industry and how they succeeded is they got this to 70%. They now figured out that, you know, in some cases, like the best discoverers are 1 in 3 and 1 in 5 get themselves into productive environments. You know, Mother Nature will dictate whether it's economic, but they consistently get here, and is why you've seen the cost of discovery go down. They figured out we got to be here all the time. We don't reward simply because you explained the seismic reflector. That was not part of your job. So, in conclusion, is that there are no missing pieces. We don't need new technology. Incremental improvements will always be necessary and useful, but there's no magic bullet out there. And the most disappointing thing is that having been part of the team of people like Ken and others and Alan, who were stewards to it, bringing many of the new technologies to the forefront in 15 years ago, nothing astounding has come from that. And it's not because we don't have good technology. As I said, my experience has been we've applied it poorly, inconsistently, and if we're really going to be better, we've got to figure out what we're doing wrong. And I put in the one thing from Peter when I first went to see him, and he looked at me and he told me, he said I was a lone wolf. He said because when he brought risk management to the oil industry, he originally went to vice presidents. And he says risk management is a way to manage managers. It's how they allocate. They have to report against the risk of their project. So nobody wanted to do it. He said he wasn't successful with his company until he walked into boardrooms. So people who spent the money, it was their money that was being spent. And I've said this at the Discovery conferences, far too often you go to the technology sessions, you won't see the vice presidents and the executives of any mining companies there. They're not interested in what we have to say. And again, unlike when you go to the high-tech sectors, all the presidents and the CEOs are front and center. Their future depends upon them. We lack, like I said, a commitment to our industry. So until the CEOs and the boards start really worrying about that 1 in 10,000 or 1 in 2,000 projects and starts demanding a higher accountability or report your risk, how do you get better and show improvement? If we can't measure performance and show improvement, why would I give you more money? So maybe we'll do better this time. Oil industry in the 70s, they had a big spike, nothing happened. It was the second run in the 80s that led to the soul searching. And now, of course, we saw, as Lee said, hugely successful in the 90s and 2000s. We've come off the 70s type spike, huge expenditures. We don't do anything different now than we did 20 years ago. So to me, hopefully, we will go through a period of soul searching. When we come back out the next time, we will actually be better at what we do. Thank you.